So good morning. Today we're going to talk about building RESTful services using ASP.NET Core. How many of you are already building APIs? How many of you using .NET Core to do it? Most of you. How many are still in Web API? In other words, .NET Framework? A few of you? Okay. All right. Well, for those of you that are already doing this, hopefully we cover some stuff that you weren't aware of. If not, it'd be a good review. Who am I? I've been speaking with VS Live since the early 2000s. My daytime job, if you will, is I'm CTO and chief architect for one of the largest law firms in the US. I've written a bunch of books. The last book I wrote is that one. I'm done writing books. Nobody reads them anymore anyway. It's all YouTube and everything else. But that book still holds water. The only thing that really isn't in it is Blazor, which just wasn't ready when I wrote that book. But if you look at what's been added in later versions of C# and .NET, a lot of it is syntactic sugar on the C# side. So it is still a good reference book. Like I said, it's 1,700 pages, so it's everything from soup to nuts. And I got a bunch of stuff on my vanity slide. So first question, if you're still on Web API, and some of you are, the good news is that the vast majority of what you are doing in Web API will work in .NET Core. You won't take advantage of all the cool new stuff, but it'll work. Now, the exception is if you're using Entity Framework 6 and you're using the designer, that's not going to work. But from an API standpoint, controllers, obviously no views, services, that will translate. Routing works the same as long as you're using attribute routing. So what I recommend, file new project, right? Clipboard inherit from one to the other. You guys know clipboard inheritance, right? It's one of the 7 key design patterns that we use. There is an upgrade assistant. The upgrade assistant's a little rough in spots, especially when it comes around to EF Core, if you're using that. But really, going from Web API to ASP.NET Core APIs, it's a very clean transition. Again, you're not going to be taking care of all of the cool stuff that's built into ASP.NET Core. All right, so let's talk about some fundamentals, just real quick. If you're still in Framework, and most of you aren't, but you're going to remember this, we had a bit of an issue in that we had all these different frameworks that were very close cousins, like with controllers. We had API controllers, then we had async controllers, right? Which one do you use? So one thing that the ASP.NET Core team has done a great job of is there's just ASP.NET Core. That's it. Everything falls under that. I put an asterisk by Blazor because Blazor has a little different paradigm, but it's still just part of ASP.NET Core. There's no different frameworks to install or download. It is cross-platform like all of .NET, and it's blazing fast. So one of the things that ASP.NET Core does is renders everything or serves it up using Kestrel. Kestrel is a derivative of libuv. Microsoft has been supporting it for a long time now, and it's just blazing fast, right? It's designed for speed, which means even though there's some security that was bolted onto Kestrel, all my friends in the security space strongly recommend that you use a true edge web server to serve up your APIs, right? So it's going to be IIS on Windows, Nginx, Apache, et cetera, those things that are battle hardened to make sure that you stay secure. All right, and that's about the last slide we're going to cover today. There are a lot of slides in there. You can download them. They're on the website. What I do is I keep this as my outline, and we're going to dive into code. All right, let's start with program.cs. So one of the changes that came in a mid-recent version of .NET Core or C# is this concept of top-level statements. So we don't need to have a program.cs anymore. We don't need to have a void main, those types of things. What we have is we have a file, typically called program.cs just by convention, but there's no requirement for it to be called that just starts into the code, right? It removes a lot of that cruft. What happens behind the scenes is it still gets compiled into a class and into a main method. So what that means is we can't have a lot of other methods in here. It also means that if you're used to the original ASP.NET Core template, which had a startup.cs and a configure services. Those are gone. What we have now is we have logically at the top of here, this was the first line in program.cs. We're creating a web builder. Then the next part of this is the configure services, where we're setting up all of our services. And then we get there eventually. We build the web server, and then we configure the pipeline. So that's configure services and configure all in one file. The nice thing about this is you don't have to go back and forth, and everything is already injected in for you that you might need. The other big change from framework is that there is no such thing as a web project. The only thing that you can get in .NET Core are console apps and class libraries. So a web project in .NET Core is a console application. That's all it is, right? But you're building up a web host, right, or this web application, and the web application gets configured. So if I run this, you will see a console window pop up. Now, obviously, when you're running in production, you don't see the console window, but I'm just proving it is a console application. Right, and then here's our API that we're going to talk about building today. The scalar documentation we're going to cover tomorrow, so I'm going to shut it down. Just wanted to prove that it was a console app. So what are we going to do? We're going to create a builder, and then we're going to configure it. So let's talk about configuration. And we're going to start by talking about dependency injection or dependency inversion. If you don't understand this concept, let me put it to you very clearly. How many of you can drive a car? And if you can't, that's fine. It's just an example, right? How many of you can drive any car as long as it has a steering wheel, an accelerator, a deaccelerator, also known as a brake, and depending on what part of the country you live in, may or may not have a turn signal? Right? All of you. Which means you understand or you can drive the interface. And you can get a rental car. You can get your partner's car. You can use a friend's car. It doesn't matter, right? That dependency, the actual car implementation, gets injected into your life, and you drive it. We want to do the same thing with our code, right? It's one of the principles of Solid. If you knew something up, you are stuck with that implementation. It would be the equivalent of you could only drive one car regardless of where you were, right? You had to have that particular car with you. You could never change cars. DI is so fundamental into ASP.NET Core that even setting up the project template is all DI enabled. So when we look at services, right, that's our service container. There's a method called add controllers. If it's an MVC app, it's add controllers with views. If it's Razor pages, it's add pages or add Razor pages. Well, what is this method? This method has a whole bunch of stuff that's injected into it. So all these dependencies that we need are injected in. And we're going to do the same thing with our dependencies. So if you're using repositories, for example, or if you're using a DB context, or if you're using other tooling, you inject that in, and you inject that in the equivalent of configure services. The way that we can inject into our application, there's three main ways, and I'm going to say with an asterisk because we've updated it. But we have scoped, we have transient. I don't think I have an example of transient in here. And then we have singleton. So how does this work? So singleton, let's cover that first. You don't have to build it as a singleton. That's handled by the framework. And what that means is there can be at most one of these things in your application. Now, it's important to note that's per your server, right? If you are behind a load balancer and you're going to two different servers, for example, you're using Azure Load Balancing and you're in two different Azure App Services, you're going to have up to two singletons, one over here and one over here, right? So singleton, it's kind of rare to use. A good use for it that we found is, for example, we use a lot of Signal R in our applications, and you have to keep track of who's connected where and keep track of those connections, and it has to live beyond the lifetime of a request response cycle. So we put that in a singleton. When you go to a load balancer, then you have to use a different paradigm. But it's kind of rare that I use singletons. Transient is also very rare. Transient is, the definition is you get a new one every time it's asked for, right? So I have this transient dependency, and it's going to be used by 5 different classes in the call chain to get to the endpoint. I will have 5 different instances of this thing in memory. So again, it's pretty rare. The only time I use transient is when Microsoft tells me to. There's certain things that you need to add in, and you'll see them tomorrow in the Razor Pages demo, that Microsoft says, here's how you add it in, and you add it as transient. The overwhelming majority, you're going to add in as scoped. And the lifetime of a scoped dependency is the lifetime of the request response cycle. That's typically what you want, right? So you make a request to my website. I'm going to create these things that the code needs to complete the request. We send the response back, and then they get marked for garbage collection. Now keep in mind that getting marked for garbage collection doesn't immediately garbage collect them, right? There's a whole garbage collection cycle. We can talk about it at lunch if you want. But there's still going to be some memory pressure, so you also want to make sure that you are only bringing in those dependencies that you need. So how do we get our dependencies into our application? Oh, before that, let me talk about this new thing. I'm going to go back to the slides for a minute because I don't have it in here. So how do we get it into our application? It's in program.cs. It is in the configure services part. In other words, it's before the web application builder.build call, right? That's where we add it into the services. To get them into a constructor, we simply pass it in, right? icar repo for repo. And that will get injected as these classes are instantiated by the framework. To use them in a method, we will typically add in from services. The reason we do this, on an action method, if an action method is taking a complex object, the default mechanism that ASP.NET Core wants to do is data bind to that thing. So it's going to be looking at the message coming in, right? And it's typically going to be the JSON body in an API call. And it's going to try a data bind. So we give it a compiler hint, say, no, this is from services. Go look in the services container for this thing. Don't try and data bind. It's important to note that as of ASP.NET Core 7 and later, from services is optional for action methods in APIs, and that's APIs only. I still put it in there, and here's why, right? If it's not in there, that means the framework has to decide, are you trying to data bind or should I get it from the services? I'm sure that decision tree doesn't take long, maybe microseconds, maybe nanoseconds, but it's more than 0. And the other thing that I find very important is to make my code very, very readable for people looking over my shoulder, or more importantly, working on code that I have written. So if I don't have from services in there, and the person looking at this code to work on it doesn't know that it's an optional attribute because we are in ASP.NET Core 10, they might get a little twitchy. And it's really, really important to imagine that the next person who looks at your code is an axe-wielding psychopath. If you can keep that in mind, you're going to write much better code. Because in reality, who's the next person who's going to look at that code? It's going to be you, right? 6 months down the line, you're going to get this PBI, product backlog item. You're going to look at this code, and you're going to go, who wrote this crap? And you go look at the commit history, and you go, ooh, that was me. Let me clean that up. So there are several things within the framework that Microsoft has said they're optional. I'm going to call them out as not really being optional, just because I think it's important to keep that code readable. Something new in 8, which was amazing that they finally added it, was this notion of keyed services. So prior to 8, I could add in 2 of the same thing, right? iService component and have it be service component 1, service component 2. And what would happen then is all of the injection mechanisms will now give me an array of these components. So it can instantiate both of them, or all of them, and then you have to decide which one to use, typically using the service locator pattern. Very doable, right? Not the end of the world, but this is so much cleaner. I can provide a key to each of these components, and so I have my simple service with this key, right? Simple service 1, simple service 2, and then in the constructor and the action methods, I have to put the compiler hint, say from keyed services, and pass in the key. And we'll see examples of that throughout the code. Another thing that I'm going to call out that you should have on in development environments but not on in production environments is the ability for an application to self-validate its dependencies. So what we want to do is we want to add controllers as services, right? That's just part of the Fluent API in our program.cs. And what that does is it makes all of our controllers treated like a service. And then when we say use default service provider or whatever service provider you're using, validate on build and validate scopes, it's not really on build, when you run the app, if there is a dependency that some controller or action method needs that you did not add into the container, the app will not start. So this is awesome in the development environment. It is the exact opposite of that in production. Ask me how I know. I brought down our app because I was working on something. I had set this up. I didn't fence it, as I'm going to show you how to fence it. And we couldn't get the app to start. And then, of course, in Azure, you're not getting any meaningful logs, right? And so we ran it local. And then you get the big yellow page of death that says, oh, you screwed up. There's a dependency missing. Let's talk about environmental awareness. And I don't mean recycling. You should all be recycling, cleaning up after yourself. But in the ASP.NET Core world, environmental awareness means that the application knows where it's running. By default, we get 3 environments out of the box. We get development, staging, and production. If you don't tell it, if you don't tell the application what environment it is in, it assumes production. The way we tell it is a number of ways. We can do it through command line arguments, as we do in our launch settings. So if I go into my properties, launch settings.json, right, we are passing in ASP.NET Core _ environment equals development. This is great for debugging. I can go into my launch settings, change that to staging, change it to foo, whatever word you want. It will pick that up. You can also do it with real environment variables. So I'm a Windows person. I don't know a whole lot about Linux or Mac, but I know that, like on Windows, for example, I can have environment variables just for me, or I can have them for the system, right? You can do the same thing in web servers, right? The server itself. So this is valid across all platforms. So this is awesome. Why is it awesome? Well, because our configuration uses this. So configuration in framework was what? Web.config, right? How many liked the web.config for all of your application configuration? Yeah, there's always 1 or 2, right? Well, the problem came with when you wanted to have different settings, connection strings, based on your different environment. Now, you could do web.debug.config and web.production.config, but the problem with that, there's a couple problems with that. The first problem from an ease of use standpoint is you could only get that final web config if you ran MS-build, right? So I can't just copy a file out. It actually has to be munched through MS-build. The other problem with that is now you have the connection string on your hard drive and checked into GitHub or whatever your source control is, right? Which, I don't know, that's kind of bad. Microsoft learned, oh, and by the way, web config still exists if you're running ASP.NET Core on IIS. A web config gets created for you, and in the header it says, if you touch this file, I will cut off your fingers. Okay, it doesn't really say that, but it's only for IIS, and it's doing what IIS needs it to do, right? IIS does not need us to configure our entire application. So Microsoft said, well, JSON is really kind of the accepted format. It certainly beat the flat XML. So let's make the default JSON. So what we get is an appsettings.json file. But more importantly, we get the ability to do this. Appsettings.json, it's just JSON, it's got to be valid JSON, that's all it has to be, right? You can put whatever you want into it. And then we get appsettings.development, appsettings.production, appsettings.staging, and that file will get loaded at runtime based on the environment that you're running in. So this is the start of this thing that's all kinds of awesome that we're going to get to called the options pattern. Now the nice thing about this, there's a bunch of nice things about this. First and foremost, I can have in my development environment, here's my connection string, right, local DB. In my staging, I would have my staging connection, local DB, because this is my machine, it's demo code. But in production, what do I have? I don't have a connection string, I have a token. Now, I'm going to tell you probably the better way to deal with connection strings is something like Key Vault, right? But if you're not going to do that, at least do this, where you have a token, and that token either gets replaced by the connection string in your build pipeline, or the people who are able to touch your servers just deploy your production JSON file out there, and you don't have to worry about it. Here's why you don't want the production connection string. When something happens to your company, everybody who has access to the production server is going to get questions. I spent years dodging that bullet as a consultant. They'd be like, oh, let's give you access to prod. No, thank you. I'm the CTO now, I have to know it, unfortunately, right? Because I'm going to be the first one they call if something happens to the company anyway. So now we've got these different files that get loaded at runtime. But there's more that we can do. So before we get into the options pattern, let's just look at this in action. So we have here we go. In program code, and you can do a lot with views. We're going to cover that tomorrow, so I'm not going to cover that today. But here I can say, if my environment is development, then go into this branch. So what this demo code is doing is if I'm in the development environment, I'm going to turn on my API, so I'm going to get my Swagger stuff done. I am going to then also rebuild the database. So I'm doubly protecting this, right? I have got a variable or an entry in my development, right? Rebuild database, true. Production, it would be, well, look at that. That would be bad. Although it would never get there, right? So you know what? I'm going to leave it that way because it proves a point. Because my program.cs will only execute this code if I'm in a development environment. Now, the nice thing about using the built-in ones is IntelliSense. So I have is environment, right? So I can do .is. Let me zoom in. Of course, it went very faint. Is development, is production, is staging. But I can also do something like this. Right, is environment local. Now, why would I do that? So the way we work is we keep a fake copy of the data on our local machine. Right, we use SQL Server Developer Edition. Don't worry, we don't have real client data on our machines. That would be horrible. But we use different tools like from Redgate to mock up data. Right, so we've got fake data. So when we're working, we don't have to be hitting the server, et cetera, et cetera. It's great for me when I travel a lot. So I've got this environment called local. I just don't get the nifty pre-built methods. So development for us is our shared development environment, right? So it's a SQL Server, SQL Azure database, right? It's not an app service. We're just using a shared database. And then we have staging and then prod. Right? So you can have as many of these environments as you want. And it makes it really simple to switch back and forth what you're working on. You could do this with Configuration Manager and Framework. You can do this by hand in .NET Core also. But what's really nice is you've got all this JSON. And you can put settings in the JSON file that you want to then put into a class so you can use it in code, right? And you can go through Configuration Manager, you can get object, you can do all that stuff. But what would be really nice is we could inject that stuff automatically into our code so we don't have to worry about configuring it. And that's called the options pattern. So the way we set this up is in our program.cs section, right? We call configure. There's the class we want to instantiate, and there's the section that we want to get. Why would you do this? Well, I already talked about the different environments, right? So when I'm running in dev, and my API has to talk to another API, guess what the URI is? Localhost : some port. If the app's in staging, it's going to talk to a different endpoint, and in prod, yet a different endpoint. And if I'm using basic authentication, like for example, on my machine, I'm going to tell you right now, password's 1234. Tell you right now, it's not that in staging, right? So instead of having to do Configuration Manager, get this value, get this value, get this value, I can say, oh, get all my settings and instantiate them from the appropriate JSON file because it got loaded. And then I can inject it either using an option monitor or an option snapshot into my controllers and my action methods. Now the difference between the two, options monitor has a file watcher that's out there, and it'll watch the file. So if the configuration file changes, it can raise some events and things like that. I will tell you, I've never used that in production. Sounds nifty, but I've never had to use it. Because if you think about it, it's a request, it's a response, the file changes, this thing's not in memory anymore anyway. Snapshot's what I use 100% of the time. Now it gets different in Blazor, but we're not talking about Blazor. Snapshot just says when this page is loaded, or when this request comes in, read the JSON, or if it's cached, right? And then build a snapshot. Less memory overhead, but still does the same benefit. And then I just get the value out of that versus the current value. So now I can inject this thing into anything that can take dependency injection, and now I have all this configuration. So we use the heck out of this in our web apps too, right? Web apps talk to APIs. It's the same paradigm. We're going to talk about this tomorrow if you come to my Razor Pages talk, right? There's a lot of overlap, a lot of goodness in both. All right, so this is kind of funny. And oh, by the way, the URL at the bottom here, it's all the presentations. It's really long. What you need to remember is schematic, not schematic like a database diagram, but schematic as in snow ski, paramedic. I'm a retired firefighter paramedic, and I'm a 32-year member of the National Ski Patrol where I'm a medic for them. So if you go to github.com schematic, look for .NET demos, drill down, you'll find the APIs, right? Or you can look at the slides. These slides should be posted with the updates already. All right. Classic framework, everything was Pascal case. So you return JSON from Web API, it's Pascal cased, right? Because that's how Microsoft lives. The rest of the internet said, nope, we're camel cased. And if you don't know what that is, camel case is lower first letter and then humps like a camel for every word, right, in there. And then Pascal case's first one is capitalized, and then the rest is the same as camel case. Well, with .NET Core, they said, we're going to fix that. We're going to make everything camel case coming out of ASP.NET Core RESTful services. And the world rejoiced until it broke every website that talked to Microsoft. Because everybody, like we use DevExpress components. And I have to turn Pascal casing back on because the DevExpress components are expecting Pascal case because I'm in a Microsoft environment. And here's the really fun part about this. There are a bunch of settings that we can do. Let's go back into our program class. Property naming policy. If I want to revert it to Pascal case, I don't set it to be Pascal case. I set it to null. Intuitive, right? And then they added other options. So if I look at this and use some IntelliSense, so I get camel case, kebab case upper. You know what kebab case is? I love the name. I did not create it. I wish I would have. Instead of having the letters marked to different words, everything's lowercase, but there's a dash between the words like it's on a shish kebab. So lower kebab case, all letters are lower. Upper kebab case, they are upper. And then there's snake case. It's not a dash, it's an underscore. Folks, somebody got paid to come up with these. Kind of wish I had that job. Anyway, to set it back, you guys set it to null. So your mileage will vary, but know that if somebody not in a Microsoft world is calling in, some client is calling into your API, they're going to probably be expecting Pascal case. So you might want to keep that. There's some other options. Property name, case insensitive. You want to set that to true. What that means is the framework won't care with casing on anything coming in, right? So you're not hampered by what the casing is. I almost always set that to true. Right indented is just, actually for the most time it does nothing, but it does make it look pretty in like scalar and swashbuckle. Here's an important one that got added fairly recently, and that highlighting makes it really hard to read. Reference handler ignore cycles. So Newtonsoft had this for a long time. System.text.json only got it fairly recently. What this will do is save you if any of your objects that you're trying to stringify has references to other objects, and those objects have references back to the first object. And you say, why would I do that? If you're using EF core, how do we do foreign keys? We have a collection of this object, and then this object has a property that points back to this object. So if you don't have this ignore cycles, what happens is you get a Stack Overflow because it stringifies this object. Oh, there's a collection of these. It stringifies this. Oh, there's a property back here. It stringifies, right? And so on and so forth. So you want to make sure you turn that on. How do we get data out of an API? There's a number of ways you can do it. All of these return the exact same thing. It's all valid ways to get data out of your API. The one that I prefer is this one here. I'm returning an OK. That's going to give me a 200. And we'll talk about controller base in a minute and all the goodness that's in there. And then here's my, whatever my object is, it'll automatically stringify and send it back as JSON. Typically, I would do action result. However, if you are using Open API documentation, you're going to want to do this first one up here, where you actually define what you're returning. It doesn't make a difference in your client code. It makes a difference in how the documentation works. These are all valid. Right, this one, I could do a new JSON result. And that's fine. There's nothing wrong with it. It just, to me, it's more work than just typing OK and putting a thing in it, which gives me a JSON result. So content negotiation. I've got some of our customers still want, not customers, co-counsel still want XML. Right? They think the 80s is still hip, and they want their data in XML. The good news is that's really easy to do. Add XML serializing formatter, then a request that comes in with the accept of application XML, you'll return XML. If your object is serializable as XML, which means all of your objects have to be marked XML serializable. And if you have any references to any other objects, you have to put XML ignore on those objects. All right, so let's look at that. So we've got objects. This one is content negotiation right here. Right, so I'm going to return all the drivers. Right, let's go back to program.cs. A couple things here, right? So I just added, that was it. That's all I had to do in my program.cs. And then my objects, let's go into my models folder, entities, let's look at the driver, right? Serializable. And then on every one of these reference properties, I have to put XML ignore on there. If I don't have that on there, you won't get an error. You'll get JSON. JSON's the default return type. So if it's not happy with you, it's just going to say, hey, you know what? I'm just going to give JSON back. I don't care what you're asking for. So we're going to run it. We're going to open up Bruno. If you're not using Bruno, Bruno's really awesome. The other one that people used to use has a bunch of security issues, so I don't use that anymore. All right, API demos, content negotiation. Let's look at the headers. I've got 3 headers. You can turn them on and off, right? So application XML, JSON. If I don't send any over, I get JSON. If I ask for JSON, I get JSON. If I ask for XML and JSON, I get JSON. It really wants to give you JSON. If I do XML, I get XML. And then you can also do CSV, right? So you can have this come out as a comma-separated value list. Now that is not out of the box. To do that, you got to work some magic. We have to build our own custom formatter. And you can do this with any format you want. Right, so this is a pattern you can use for CSV. You can take this code. I got it from ChatGPT, so you're welcome to have it. Sorry, Copilot. We're creating a new text output formatter. In our constructor, we're adding a media type, text CSV, right? That's what we're supporting, and we're going to support UTF-8, right? So you have to set that up. Then CanWrite is just going to determine whether or not it's going to write it out, and then this just uses reflection to loop through the properties and dump out the values. Right? That's reflection 101. The important thing is, what header am I looking for? What encoding, right? And then you have to write this text back. You write it to the screen. This actually helped. We were sending Excel files. We had a service that was running that would send an Excel file of the co-counsel's cases to them via email. And they're like, we want it on a more frequent basis. We want it on demand. I said, great, call this endpoint. Now you get your CSV, Excel, on demand. Right? And all we had to do, because we already had APIs to get data, we just changed it to have the output. Let's talk about data shaping. This is something that we've used occasionally. So let's talk about the concept. I have an entity that's got 8 properties, and I only want to send back 2 of them. Well, what do we normally do? We just send back the 2, right? We create a view model. Well, this allows you to let it's like OData. So the client can say, this is the data that I want, and then you're dynamically going to give them that data back. If you're using Newtonsoft still, and Newtonsoft is a solid project, I don't know if you're aware, but James Newton King, who wrote Newtonsoft, now works for Microsoft. He has for many years now, and he's the one making system.text.json so much better. System.text.json is lightning fast compared to Newtonsoft. Still doesn't have support for dynamic. They almost had support for dynamic, but they couldn't make it work without introducing a whole bunch of cruft. So what we have to do is we have to dynamically build up our object. So in the code sample, I'm specifying what fields I want, right? It's a very fragile code sample because you have to know the name of the fields, right? There's so many better ways to do that, but again, it's demo code. And then I build an expando. Let's get into the code for that because that is worth it. You know, that's the post, here, get from query. Naming is hard. You know what the 3 hardest problems in software engineering are, right? Naming conventions and off by 1 errors. Data shaper shape data. There's the interface. Let's go into it. So I have a shaped entity that I want to return, and the shaped entity is an expando object. I'm always going to have the ID and then my expando object. And expando is like a dynamic. It's just a little more performant for what we're doing here. So then we go through and shape data. So I create a new expando. I find the properties of all of them. I'm looking for the ID. I then get the ID, set it, right? And then I go through all the fields. And if I find a field that matches the name that was sent in, regardless of the case, as in uppercase, lowercase, then I go through. This is a little more complex because what I do is if my property is a class, then I call, it's just recursively calling into it, right? So loop through. So it can be much simpler, but I wanted to show you something hard. So then I just go through and I come back with this object. So to see this in action, here's my data shaping. Oh, let me get back to this. If you're using Bruno, and Bruno's free, the repo itself has these Bruno files in it. So let me go to open in File Explorer, and then here's my code. Go up a level, go up a level. Bruno API demo. So these are Bruno files. So all of these API methods, or these calls here, in this group here, they're in the repo. So if you just open Bruno and point to the collection that's in the repo, then you'll get all these tests. One of the really nice things about Bruno. So we do that. We have these suites of tests in all of our repos at work. All right, data shaping. We're going to get first name, last name, and timestamp. So I run this, and I get first name, last name, and timestamp. And if I don't want the last name, I just remove it from the request, and I run it, and last name's gone. Let me restore it so I don't mess up all my future demos. And then if I don't pass anything in, I give them everything. I'm still breaking it down. So I'm using some advanced, I won't say advanced, some recent additions into EF Core where I've got properties, classes that represent properties on my entity. So this breaks it down for them and adds in the full name property. Posting it is a little more complicated because we don't have dynamic capabilities in system.text.json. So let's say that I want to change, and again, this is not what I would call a production implementation, but it is a good example. I say, okay, first name is Mr., last name is Slate. If you're a fan of Flintstones, you know what I'm talking about. So we go back here, and I got Fred Flintstone and Barney Rubble, and then I'm going to post this in there, and now it's Mr. Slate. So I go back here, I query it, and I got Barney Rubble and Mr. Slate. So the way we post it, we call update data, which is the opposite. So here's all the values coming in. It's coming in as a dictionary. So I find the property, and then if it's complex, I handle it. If it's not complex, then if it's not complex, I just update it. If it's a complex property, I keep navigating down until I get to the actual property. So first name is actually not on the repo or the entity itself. It's down a layer. But that's a way that I'm demoing doing updates from data shaping. The ability to data shape coming out, I think, is a good one to have in your back pocket. You know, it makes your API much more like an OData call without having to implement OData and everything else. The ability to update data by passing in certain parameters, I think that's a little sketch. The way I would program that in real life is I would just have a model, right? Here's a view model of what you're allowed to update. I'm not going to expose a person's salary, but you can update the spelling of their name, right? And that is controlled by, hey, it's not in the model, you can't update it. But I wanted to show it in case, you know, you're sitting there going, oh my gosh, that's great. I wish I could do that. All right, let's talk about cores real quick, and I'm going to show you how not to do cores. Oh, yeah. In this code, it'll blow up. I mean, there's no error handling. It's demo code. So if they pass an invalid string, I mean, you'd actually have to check. Actually, I don't think it'll blow up. I think it will do nothing because I'm checking for property name. Well, let's try it. All right, Bruno, data shaping. I just restarted the app, so when I restart the app, I recreate the database each time because I'm in development. So I'm back to Fred and Barney. We're going to post it, and we're going to call it last one name instead of last name. And, oh, it just didn't update it. So my code had ignored it. On the get, I think we'll just ignore it also. Yeah, it just ignores it. Because it's using a reflection to try and find a match. I mean, obviously what I'm trying to show you is the concept, not all the error handling and everything else. Good question, though. And typically with demo code, if you pass in something that's unexpected, it just blows up, right? All right, CORS, cross-origin resource sharing. So if you're doing static server-side rendering, as in web Razor pages, MVC applications, server-side Blazor, SSRS, you've got everything's running on the same server, right? So you're rendering the output to the client. In that case, it's a human or a web browser. It's all the same service. It's not a cross-origin request. But if you've got a web site or a web application, Angular, Blazor, WASM, right, React, that's calling into your API, by default, it will get denied, right? Because you don't want to have denial of service attacks, things like that going on. So we have to opt in. And I told you I'm going to show you how not to do it. And this is exactly how not to do it. Because I'm saying, hey, I don't care who you are, come get my data. So you want to have something much more refined. And in Microsoft's credit, if I uncommented allow credentials, then it would say, I can't let you do that. I can turn everything else on. But if I turn all four of them on, then I'll get a compilation error. All right, so I set up a policy. And typically, you're going to have multiple policies, right? And then I have to, this is in the configure services part, right? So I'm adding it into the services container. And then I have to update the pipeline, the HTTP pipeline, to do that. So I say use CORS, allow all. Right, so that's my name of my policy. Typically, you wouldn't use magic strings. You'd have some constant somewhere in your app, right? So this would allow, if I run this, and you've got a little, web application on your, Blazor, WASM, or something, and I gave you the address of my machine, you could hit it. And CORS, you can shut down by, right, headers, method, get, post, delete, etc., certain credentials, and by origin. I am going to briefly talk about, and I'm going to pronounce it this way on purpose, HATE, OAS, hypermedia as the engine of application state. Conceptually, it's not a bad idea. Instead of having an API with a whole bunch of endpoints that are just documented, you have an API with a few endpoints that document the other endpoints, right? So let's say I have this endpoint account type, so it's, get my functions, whatever. Here's an account number, right? So it's going to return an account number, checking, and then here are the other endpoints that you can hit. So conceptually, if there's zero balance or it's below the minimum balance, you could not send, your response could omit the withdraw endpoint, which they would already know it anyway if they ever called any other thing, right? So conceptually, I get what you're trying to do. The downside of this, there's several in my mind, which is why I don't use it, but I want to call it out. It's very easy to do, right? Is you're just emitting JSON. But now, how do you build a Swagger doc around this? And how do you handle versioning? Right? It gets a little complicated. But, this might appeal to you, so I wanted to include it. So about binding real quick, we're going to just go through some more basics. We're going to go through this pretty fast, but there's some things I just want, if you're using this for a long time, then there's some things that probably good review. I said before that any action method that doesn't have the from services tag and has as a parameter an object, it's going to try and model bind. With the asterisk being an ASP.NET Core 7 and later, it's also going to look in the DI container. The way model binding works is very simple. It is going to be looking, well, for this, it's the request body. So a JSON body comes in. It will then try and convert that JSON into this object it's trying to bind to. This is very clean, right? When we're in Razor Pages and other MVC, it's a little more complex. I use a lot of reflection, but it's just like text.json, right? Build the object. If that works, woohoo, right? We're golden. There's this object called model state. Model state has a dynamic dictionary, and the dictionary is for every property in your object, it gets an entry. So if there's any errors in binding, right? Now, if it can't convert the JSON, it just model state is valid equals false, right? So there's I'm not showing it. In any post method where you're taking in an object, if model state's not valid, there was a problem converting the data coming in to your target object, or there's a validation issue. So it could have the right name, date built. It could have a value that can be converted, looks like it can be converted to a date, right? And can be converted to a date, but you have a validation on that date built field to say it must be greater than 1990. Right, so all those errors get put into model state. Model state is a property, looks like a property, it's really a method. I don't know why they didn't make it a method, because what it's doing is it's looking at all of the things that happened and determining if it's all valid or not. But it's a real quick check. If model state's not valid, something went wrong, the convention that we want to do is return validation problem. This is not my method. This is on controller base. A validation problem is an RFC spec that you should return if there's an issue. That's model binding. We talked about validation. You can write your own validation. How many of you have written your own validation attributes? Oh, a fair number of you. Good. For those of you who haven't, I've got really good samples in the code. Let me look at logging to show you logging real quick. We use Serolog. If you ever use Log4Net or nlog or any of those, Serolog is the current thing that, it's the current hotness. They were really the first one to adopt .NET Core. And it's really powerful. So the way Serolog works is it has a bunch of sinks. And every sink that you turn on is where the errors get written to. Right? So in this example, I've got a file sink, and I've got a console logger and a database logger. So I write an error, and then based on the severity, it'll write to all of those at once, right? And there's sinks for application insights, all kinds of stuff. I'm using SQL, they've got it for Oracle, everything else. But the important thing to note, the first thing you do is you clear out the existing loggers. So ASP.NET Core, by default, gives you a console logger. And you don't want those loggers, you want your logger. So I'm clearing them out. I can also do this with my DI container. If you don't like the built-in DI container, you can clear it out, and you can use something like Ninject or Autofact. You can plug it in. I personally haven't had an issue with the built-in one. All right, so if you remember in Framework, we had API controllers and we had controllers, and they had different functionality. The way they've cleaned that up in ASP.NET Core is very nice. Controller base has all the non-UI related functionality. And it's got a ton of helpers. Like I can return OK. OK is a method on the base. It's going to build an HTTP response message that has a status code of 200. What's not in controller base is return teapot. You're going to have to build that 418 by hand. OK, object result really works the same as object, but there's no content. So all these different helpers that we have in there. Controller inherits from controller base, right? And controller has the UI stuff. So we'll talk about the controller class tomorrow when we talk about Razor Pages. All right, this is an important note. Get is the default verb for all action methods. If you don't decorate an action method with a verb, what verbs can you use with that action method? Anyone? All of them. Get's the default, but all of them can be hit. I got burned by this a bunch of years ago. I was doing some work for Microsoft as a red badge, or a V-dash, and I didn't decorate it with get because it was a get. And it failed a security audit because you could hit it with a post and a delete. Now, the code didn't do anything, but it's still a security issue. So you should always, 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 always decorate your methods with the verb that you want to be able to hit. Oh, shit, the answer to the question is right on the slide. So those of you that were reading, all right, API controller attribute. This is really important to understand. In ASP.NET Core, of the modern releases, every API controller, in other words, any of your controllers that inherits from controller base that is meant to be an endpoint for API calls has to be marked with the API controller attribute. This is their distinction of if you've got an MVC, Razor Pages, and API all in the same project. Conventional wisdom says you probably should have separate projects, but hey, real life happens, right? And sometimes you have these things in there. The API controller attribute gives you some benefits. If you want, you can get automatic 400 responses on any model validation error. I turn stuff off. Binding source parameter inference. What does that mean? We used to have to say from body, from form, from route, from query if we wanted to specify where things came from. With the API controller attribute, that's inferred, right? From body for a complex type, from form, if there's a form file or form file collection coming in, from route, any parameters where the name and the data type match the route automatically go from route, and then from queries, everything else. To turn these on and off, we go back to program.cs, and we configure the behavior. So I suppress the model state invalid filter because I want to control it myself. This is by default, suppress map client errors is already false. I just call it out. And then here in my problem statement, if I return a problem details, I can specify different links for certain error codes. Routing real quick. If you're still using a route table, you shouldn't be. The default way you do routing in ASP.NET Core RESTful services is with attribute routing. And the way attribute routing works is there attributes. Controller is the top level. So you would do a route like this. You can have multiple routes. We'll talk about versioning tomorrow. I can also overwrite a route if I wanted to. I don't recommend it. Every action method will inherit the route above it. You can append to the route in your verbs. So here I'm adding an ID to the route. APIs support all verbs, whereas like a web application only supports get and post. Last thing I want to cover is filters. I think they are extremely important in APIs. They're not as important in web applications. What I have here is an application level filter called custom exception filter attribute. It inherits from exception filter attribute. I've decided to pass in a web host environment. There's only one thing to override on exception. And what this does is if there's an exception, let me reword that. If there's an unhandled exception in my code, right? So we've already got all the way back up to my controller action method, and there's an unhandled exception. This kicks in. So I highly recommend you do this in your APIs, right? And so this is a very silly implementation. If I'm in development, I'm going to include the stack trace in my response. Otherwise, I don't. There's the exception message, and then I just did something really silly here. If it's a concurrency exception, I just say it's a concurrency. Otherwise, I just throw 500. You could say exception handled equals true, and then it just swallows it, and then execution will continue. So this would be the equivalent of, hey, I want to get notified if something bad happens, but let the bad stuff continue, which doesn't make sense to me to do. But again, you might have a need to have it just continue and silently log it. Let's go back to validation attributes. We're going to talk about them tomorrow also, but we're going to talk about them tomorrow in, where did I put them? So obviously there's no UI, so we're not going to talk about client-side validation. But I have a must be greater than 0 attribute that inherits from validation attribute. Ignore iClient model validator. This code is used in multiple projects. I just copied it out here. Here's my constructor, here's my default message. I format the error message. And the only thing that we care about in APIs is valid. We get an object that is the value being passed in, and the validation context gives us access to the entire model that this property is being validated for. Why does that matter? Well, this is a very simple one. I'm just using pattern matching. If it's not an int, then I return an error message. If it is an int and it's less than or equal to 0, I return an error message. Otherwise, I say validation success. This gets rolled into model state for you when you decorate your property with this attribute. Why does the context matter? Here's one. Must not be greater than attribute. And suppose you're building an e-commerce site and you have 5 in stock and they want to order 7. Well, now I have an attribute that says must not be greater than, and so it's going to programmatically look at its value. It's going to get the other property's value, and it's going to just determine if it's greater than or, greater than the other value, and then add that to model state. So with these validation attributes, if you find yourself writing validation logic, and you write that validation logic more than once, and this goes for any programming. If you write something once, think about making it a function. In this case, validation, make it a validation attribute. If you write the same thing twice, I'm going to say you have to make it a validation attribute. If you write the same thing 3 times, I want you to stop developing. All right, like I said, I'm going to go back to the slides. I have a blog. I don't blog anymore. I'm on Twitter or X or whatever. I'm pretty much on most of the socials, and I'm not really doing much on them either. But my repos are very active. Schematic, github.com. If you loved this session, remember my name is Phil. If you thought this was terrible, my name is Ted. Thank you very much. I hope to see you all tomorrow.